All right, let's take a look at some factoring problems. We're going to break it down into a couple different little sections here, like some of the strategies that I need you to be aware of. The first will be greatest common factor, just pulling out your GCF, and then we'll do difference of squares. And then the basic trinomials where the leading coefficient is 1. We'll do slip and slide trinomials where the leading coefficient is not equal to 1. And then we'll do factoring 4 terms, which is also known as grouping. All right, so let's start with GCF. This is the easiest one that we need to kind of make sure we have straight in our minds. So typically when you're factoring, the first thing you want to do is always identify and take out your greatest common factor. All right, so here we're just going to look for any factors that are common between all of the terms. Some of them will have 2, some will have more than that, but any common factor that we see in all of the terms, we're going to take that out and turn it into multiplication. Okay, so if I look at this first term 12a and then this negative 27, I know that the common factor would be 3, right? So I could write 12 as 3 times 4 and then multiply that by a, and then 27 would be 3 times 9, right? So when I say common factor, what I'm doing is identifying whatever number is being multiplied that is the same in all of the terms. In this case, there's 2, right? So I'm going to take that out. So I'm going to turn this into multiplication. So I'll put the 3 on the outside. We'll open up our parentheses and we'll think about what's going to be left. All right, so what's left here would be the 4a, and then what's left in the second term is 9, and this was a subtraction problem, okay? And we can check our answer by distributing. So I can do 3 times 4a, that would be 12a, that was in our original problem, and then I can go back and make sure that 3 times negative 9 is negative 27. So when I get the same answer back, I know that I did this correctly. All right, okay, so that's the first one. So same idea on all of these, right? We're going to take a look at any common factors that we see. Between 16k and negative 24, there's a factor of 8. So we'll take out 8, and then we'll be left with 2k minus 3. Then in this one's a little bit different than the others because not only do we have coefficients in front of our w's, but each term has a w in it, okay? So if I was to break this down, if I was to kind of do that little factor tree here, I know that we have 12 times 4 is going to give us our 48, but then I also have 2 factors of w, right? That's how we get the w squared. And then this one, if I was to break this one down, I know that we have, 12 times 3? And we have 1 factor of w. All right, so when I identify the greatest common factor, I'm looking for things that are the same. So we know that we have a common factor of 12. All right, so each of them has 1 12, and each of them also has 1 w. Okay, so that's going to be our GCF, and we're going to put it out in front of the parentheses so that we can turn it into multiplication. Okay, that's what a factor is. It's the things that you multiply by to get your original. So the greatest common factor here is 12 and only 1 w, and what I'd be left with would be this 4 and this w in the first term, and I'm just left with this 3 in the second term. Okay, and again, if I wanted to check that, I could go back and distribute and make sure that I end up with the original problem. All right, so identify your GCF and then put it out in front of your parentheses for multiplication. All right, so this one, in number 4, has not only coefficients, but it also has x's and y's. All right, so if I was to break down 75, we could do 15 and 5. So we have 15 times 5. Then I've got 2 factors of x. That's how you get the x squared. And then I've got just 1 factor of y. All right, I'll do the same idea on this 120. So I know that 15 times 8 is 120. I've got 1 factor of x and 1 factor of y. So if I was to go back and try to identify the GCF, we see a factor of 15 that is common. We see only 1 x that is common in both. And then we see 1 y that is also common in both. Okay, so I can take that out. So my GCF, if I was to just identify it, would be 15xy. Okay, and that's the number that we're going to put out in front, or the term really, that we're going to put out in front. And then we're going to just write down whatever's left. So we have 5 and an x that's left in the first term, and then we're just left with 8 in the second term. Okay, so the better you are at mental math, kind of identifying your factors, the easier it is. But if you can break down your numbers and identify anything that's in common, that's how we take out the GCF. Okay. All right, so 5 is slightly different because we have 3 different terms and we have A's and B's. So let's see if we can break this down. The 4 would break down into 2 times 2. We've got A times A times A, because we have A cubed, and then we have just one B. Okay, that's how you would break down the first term. The 8 would just be 4 times 2. Then we've got 2 factors of A and 2 factors of B. And then here, 2 is just 2 times 1. So we can break that down, 2 times 1, 1 factor of A, and then 3 factors of B. All right, so now we'll go back and individually take a look at any numbers or variables that we have in common. So I notice when I look at this, each of them has a factor of 2. Okay, so I've identified a 2 as far as my GCF, at least, from the coefficients. I have 3 A's in this one, 2 A's in the second, and only 1 A in the third. Okay, so the maximum amount, when I say greatest, the maximum or the greatest amount of factors of A that I could take out would only be 1, right? Because I've got 1 here, and then I can match it up with this 1 here, match it up with this 1 here, and I can only take out a maximum of 1A, because that's only 1A is what's in common between all 3 terms. So we can take out 1A, and similar idea for the B. So in the first term, I see that factor of B. I can match it up with this factor of B, and I can match it up with this factor of B. All right, so each term has at least 1 B. Okay, so the maximum amount of B's that I could take out would just be 1. Essentially, if you want to do this quickly in your head, you basically take a look at the variables, and whatever the lowest power is, that's what you take out. So we noticed that the lowest power of A was A to the first in the last term, and the lowest power of B was B to the first in the first term. All right, so that's the max that we could take out. So our GCF is 2AB, and then we would write out whatever factors we're left with. So we're left with a 2 in the first term, and then A times A is A squared. In the second term, we're left with 4 times A times B. And in the last term, we're just left with 2 B's, so we're going to write that as B squared. All right, and again, you can go back and distribute to make sure that you did this correctly. And then we'll take a look at the last one here, number 6. So let's break down 30, 12, and 6. So we can kind of do this one mentally. We don't have to do those factors trees. That's just to kind of show you why this stuff is working and where it's coming from. I know that between 30, 12, and 6, the greatest common factor would be 6. All right, so I'm going to look at my M terms. I got 4 of the M's here, 3 here, and 2 there. So the maximum number I could take out would just be 2 from each group. All right, so between 4, 3, and 2, I can take out 2 from each. Okay, and then with the n's, I have n cubed, n squared, and then n to the first. So take out the lowest power, n to the first. Each of them has at least 1 factor of n that is in common between everything. So we'll take that out, and then we'll think about what we're left with. So if we take out a factor of 6 from 30, we'd be left with 5. If we take out 2 of the m's from m to the fourth, we'd be left with m squared. And then n cubed, if we take out 1 n, we'd be left with n squared. And then for the middle term, if I factor out a 6 from 12, I'd just be left with 2. If I factor out m squared out of m cubed, you'd be left with 1m. And then if I factor out an n from n squared, you'll be left with 1n. And then we'll do the same idea for the last term here. So since the GCF and the coefficient of the last one is the same thing, it's really a 1. You can write the 1 or not write the 1. And then it's the same idea for the m squared. So we're taking out the entire factor, and then the same idea for the n. We're taking out the exact same thing. So altogether, we would just multiply this by 1, because the term in the polynomial is the same as the GCF. Okay, so again, if I was to distribute that, I know that 6m squared n times 1 would give us back this original. Okay, all right, so I'll do another video on difference of squares.